So right over here, residual. We talked about regression. Regression is the line of best fit. And these are going to be some crazy equations. We're going to have some decimals for slope, decimals for the y-intercept. The residual, though, here very formally, is distance from the point y to the line y hat. What does y hat represent?
Oh, wait.
The notation. Is the line of best fit, but it's the?
Notation.
Notation of regression. Okay. We're actually going to be working here. We're actually using the data from what we got on the last section, which is number of letters in your name versus time it took you to write your name 20 times. Okay. What I'd like for you to do is just go ahead and put these, so 330, 430, all of them, on these first two columns. So what I mean by that is putting 330, 430, 550, 560, 780, 870. Okay, top like that. You're like, I don't understand.
You wouldn't be my teacher anymore.
Okay. Now, the residual, very informally, all it is the vertical distance from a point to the regression. That's all it is. Okay, this is how we compute it based on here. We had the regression from our previous notes as y hat equal to 10x. And I'd like for you to look at this. Now, looking at all these points, I want you to tell me, so this first one, this point compared to the line, how far is it away from the line?
It's on it.
It's on it. So that distance is?
Zero.
Zero. Here, this is, right, looking at the vertical distance, how much is it below the line?
1.
10.
Negative 1.
You would think it would be 1 or negative 1, but we're going by units of 10. So how much is this below the line? 10. We actually classify this as negative 10.
But it's
10 below.
distance.
Here,
You have negative distance.
the distance? 0, right? It's on the line. This one up here, how far is this away from the line? 10. Here?
10.
And here?
10.
This would be negative 10, right? Just like we talked about, it's 10 below.
But you're talking about distance, aren't you? How do you have a negative distance?
So for this, it is classified as distance, but we want to, there's a way for, if it's above, it will be positive, if it's below, it's negative. What should happen is there should be like some canceling out. That's why we have negatives here. But typically, like in a normal real life instance, we don't classify like distance as negatives. But it'll help us here. Now, for this, to classify or to get the numbers in this row, and those numbers that we talked about for residuals, they're going to come up. For predicted, this regression is the line of best fit, but it's predicted, right? Not everything will follow this. Not every single time when you write your name 20 times will it increase by 10 per letter. Okay. So what we're going to do to find this row is we're actually going to plug in our first column. All right, so what I would do to find out this output is I would plug 3 into here. If I plug 3 into there, what is our output? 30. For the next one, our input is 4. Plug that into here. Output is 40. Next one is 5.
50.
Our output will be 50. And I think you guys can see the rest, right? This will also be 50.
70,
80.
70 and 80. Okay. So what this represents, these two columns are the actual coordinates. But these two columns right here, this is where it lies on the line. Now we talked about the residual being the distance from the point to the line. That's where this comes in, or we have y minus y hat. To find the residual, you just subtract these two values. Okay. So 30 minus 30 is? 0. Now I'm going to stop right there, and I'd like you guys to stop right there. Do not continue. The reason the residual is 0 is we talked about it. This first point is on the line. Okay, so that's why the residual is 0. Next one.
Negative 10.
Negative 10. So what does negative 10 mean?
It's 10 below the line.
It's 10 below the line. Right? That was this point right here. Okay. We can tell the residual based on the graph or based on the table. The next one is 0. What does that mean?
It's on the line.
On the line. Next one is 10. 10 above the line because it's positive. Next one,
10.
and last one.
Negative 10.
Okay. So we have all these points, right? 2 points being on the line, 2 points being below the line, and 2 points above the line. Okay. Now over here it says the sum of these residuals. If you added up all these numbers here, what does that equal?
0.
0. I'd like you to put a 0 there. What this means is if we found a line that best fits this, the points above the line and points below the line, they kind of cancel each other out.
Regressions.
Yeah. So like that we found a line that's probably like in the middle of all these points. Okay. Typically when it's equal to 0, that is the regression. If it's not equal to 0, then the line that you have is not the regression. Okay. All right. The lecture you guys do is let's go down here on residual plot. Okay. So again, you can find all these values. We found them through a table, but you can just find them very informally based on the graph, right? That is 0, negative 10, 0, positive 10, positive 10, negative 10. Okay. But there's a couple of things that we need to identify, and it comes with the residual plot. Okay. Over here, this is our x-axis, and this graph looks super weird. We're going from 3 all the way to positive 8. There's a reason for that, because our x values here.
Wait, why is there an E on top of the line?
I want to talk about that.
Okay.
So this graph is not an x and y axis, nor is it a scatter plot. Okay, those are two different things. The residual plot measures two things. The inputs are x values, and E, which represents the residuals. Okay. So for this actually represents the distance from the line. Okay. What we're going to do to actually graph this, you're going to use this x column and this E column. So I want you to write use x column and E, and then in parentheses I want to put residual column. Right, if we're creating a residual plot, we're going to need the residuals. It's in the name. I'm going to draw the following thing. You don't have to. I'm actually going to circle this and this. Now, I think this, of all of like line of best fit units, this is probably one of the things that students get confused. They're like, how do I graph this? What numbers do I use? Right? It says it on the axes, but use the very far left, use the very far right. Okay. Now, typically this will actually start at 1 or 2. So what I'm actually going to do is I'm going to put a double line like that, which indicates we're kind of cutting that x and y axis. It's like me cutting off your shins, attaching feet there.
Okay.
Small.
That works.
I'm not gonna do
That'd be so rude.
Tomorrow's lesson. All right. So the first coordinate is 3, 0.
That's like,
So
you sound like you're crying.
3, 0. That's what.
I'm scared.
That's right here. What's the next coordinate?
4, negative 1.
Oh, actually forgot. We need to fix these units too. Can you go and put slap a 0 underneath or under these?
Lap it.
I'll put another 0 to that 0.
All right. Actually, should I have done that? Yeah. All right. So 4, negative 10 is right here. 5, 0. That's the next one on the line. 5, 10. It's 5, but then above it. 7, 10. Go 7 on the x-axis, go up 10. And then 8, negative 10. Okay. So what this is creating a residual plot with our data. Okay. There's two things I'd like for you to write. Whether there is a pattern, I'd like for you to write pattern equal to, give yourself some room to write something because I'm going to write something else. And then if it's random. Ooh, let's put a cloud.
How fancy.
Gosh,
I'm not going to draw that.
like I'm good. All right. If the residual plot is random, what this means, and this gets into the back of a page. This means that the line that we drew is a suitable line. So the regression that was on here is a good fit for the data that we have. Okay. And this, is there a pattern here? No, there's no apparent pattern here. Okay. But if there is a pattern, that means it is not suitable. So maybe that the line that we drew probably wasn't the best line. Maybe it wasn't even the regression. Yep. Or maybe there was another type of function that would have better fit this. All right, before we get to the last part of our notes, actually, what? Turn it over. There's something else I want to show you.
Oh yeah.
Mole work. So we're actually going to work out a couple different examples. The residual plots are already drawn for you. We're going to describe them. But before we get to that, I'd like you guys to look behind you guys. Please go ahead and turn your desks around. Going to this, there are ways that we can describe this as suitable, but we're also going to describe the strength. For the first one, is it suitable?
Yes.
Yes. All right, so with red, you can put this in any color. I want to put that the residuals are random and close together to this line. Okay, so how can we describe this?
Suitable and strong.
Good. So we're going to describe this. So it's described as, I'm going to put strong, suitable. And underline both those words. Now, I don't want this to be misconstrued as when you describe the correlation coefficient. Right, the correlation coefficient, you could have strong positive, weak negative, all that stuff. They do have some commonalities in that we're describing the strength, but we're not describing the slope. The next word is whether this line is a good fit. We describe that as suitable or not suitable. Okay, next one. Is this random?
Yes.
Yeah.
So I'm going to put residuals are random. But let's also describe the strength. Is this a strong
No.
residual plot? No, right? It's really far away. It's really scattered here. So I'm going to put that it is, I'm going to put random and loose. Okay, so how can we describe it as? So described as weak, suitable. Yep.
How would it be suitable if you're 3 on top and 4 on the bottom?
So maybe for this, the line that we have isn't actually the regression. It's probably just a line of best fit then, right? Because we're going to have a little bit more below. So it'll probably be a negative number. But you can still describe residual plots from line of best fits and not regressions. Okay. That's a good question. All right, here. What's happening?
They form a pattern.
So this is a pattern. So once you write pattern, right? These are apparent, just like the examples that we had in the back. Those are apparent. So if it is a pattern, this means that a line. So I'll put line is not suitable. There's another type of function, maybe that we haven't learned about. You're actually going to be learning about a lot of other functions, but this line is not suitable. Maybe